Hello everybody. This video is going to cover our 7.2 notes over cylinders. Cylinders are not a prism, but I like to compare them to prisms because cylinders are a three-dimensional shape that contain two bases, just like a prism contains two bases. Some of the other three-dimensional shapes that we talk about, like cones and pyramids and spheres, those things either have one base or no bases. So a cylinder is just another type of three-dimensional shape that has two bases. So the really cool thing about cylinders is the formulas for the lateral area, surface area, and volume are actually the same formulas as the prism's formulas. So just as a reminder, your lateral area is going to be P times H, where P stands for the perimeter of the base and H stands for the height of the cylinder. Now, the only difference with a with a cylinder is that your base is always going to be a circle. So the perimeter of your circle is always going to be 2 pi r, which is how you find circumference of a circle. But instead of trying to remember the different formulas that there are, we just say it's P times H, okay? Your total surface area is, again, P times H, and then we have to add on the two bases. And then the bases here in this case, again, is going to be a circle. An area of a circle is pi r squared. And then volume is big B times H. And we're ready to go. So we need to find the lateral area, surface area, and volume of the cylinder. So just like when we were working with prisms, I want us to write down a P, an H, and a B. Now P stands for the perimeter of the base, which remember is the circumference of your circle, and circumference is 2 pi radius. So this is going to be 2 pi r. So this is going to end up being 6 pi meters. In a cylinder, your bases are the circles. I'm just going to highlight these like I did in the last set of videos. And then the height is always going to be the line that is connecting the two bases together. So the height is going to be 6 meters. And then big B is area of your bases, which is pi radius squared. So this is going to be 9 pi meters squared. So now that we have all that information, we can plug them into our lateral area, surface area, and volume formulas. So lateral area is P times H. P is 6 pi. Height is 6, so this will be 36 pi meters squared. Go away. All right, total area is P times H plus, now we've got 2B. So P times H we already got was 36 pi. And then big B in this case is 9 pi. So I have 36 pi plus 18 pi, which is 36 plus 18. That is 54 pi. And that is meters squared. And then I come all the way over here for volume, which is big B times H. Big B is 9 pi. And the height was 6, so this is also going to be 54 pi, but this is meters cubed instead of meters squared. So that is how you would find the lateral area, total area, and volume of a cylinder, just like a prism, okay? All right, so example number 2. It says a cylinder has a lateral area of 70 pi square centimeters and a height of 7 centimeters. So find the length of the radius. Okay, so I'm just gonna like do a quick draw of this. So here's my cylinder. We do not know what our radius is. It gave us a lateral area of 70 pi, and then it also told us that the height is 7. So just as a reminder, lateral area is P times H, but I need us to be more specific. P stands for the perimeter of the base, but our base is a circle, so that's really 2 pi r. And then I've got to multiply that by the height of the cylinder. All right, so lateral area is 70 pi, and then I just am going to plug in what I know over here. I know my height is 7. So we've got 70 pi equals 14 pi r. Your pi's cancel. We can divide both sides by 14. 70 divided by 14 is 5. So the radius should be 5 centimeters. Ooh, we're moving away from meters, going on to centimeters. That's how you would do a problem like that. Example 3, a cylinder has a volume of 512 pi cubic inches. If the radius is the same length as the height, find the radius of the cylinder and the lateral area of the cylinder. So again, I'm going to go ahead and draw my cylinder. Ooh, this is ugly. Ugh. Okay, so they're telling us that the radius and the height are the same. So because they are the same, I'm actually going to make both of these the same variable, just to make our lives a little bit easier, okay? Now, it told us that we have a volume of 512 pi. So volume of a cylinder is big B times H. As always, we need to be more specific. So big B is the area of the base, and our base is a circle, so that's going to be pi r squared times height, and I'm going to plug in what I know. I know that my volume is 512 pi. I know that my radius is going to be x, and I know that my height is also x. So now I'm just going to simplify. We have 512 pi equals x squared times x is x to the third, in case you have forgotten your laws of exponents rules. When you multiply like bases, you add your exponents together. My pi's cancel, and now I have x to the third equals 512. So we now have to cube root both sides. So I'm going to remind you how to cube root in this calculator. You want to go to math, which is the third button down on the left side of your calculator, and then you want to look where you see the cubed root, which is option 4. And then we're going to type in 512, and we get 8. So x is going to equal 8, which means that our radius is 8, and our height is also 8. So now it says find the radius and find the radius of the cylinder and the lateral area. So lateral area is P times H. So I need P and I need H. H is 8. P is the perimeter of the base, which is just circumference, which is 2 pi r. So that's 16 pi. And then I'm just going to plug it in. 16 pi times 8 is something I don't know. 16 times 8 is 128. So lateral area will be 128 pi, what is this, inches squared. And there you go. Example 4, a metal worker has a solid piece of steel in the shape of a rectangular prism. He bores a cylindrical hole entirely through the length of the prism as shown below. The diameter of the cylindrical hole is 8 centimeters. What is the approximate volume of the remaining steel? So although this is a little bit funky to see, I'm going to take this and move this back here. And what I need us to try really hard to imagine is that this cylinder here is empty space. Okay, it is a hole that goes all the way through this rectangular prism. So the best way for me to describe this, if you're having a hard time envisioning it, is think about like when you make a bracelet with beads, how there's like a solid bead on the outside, but then there's a hole on the inside for you to string your usually string through, right? The hole is usually cylindrical, and then there's bead, there's like plastic or whatever it is that you're working with that takes up the outside part of it. So our goal is to find the volume of the outside portion of the steel. So essentially what we're doing is we need to find the volume of the prism and the volume of the cylinder and subtract the cylindrical volume out from the volume of the prism. So we need to do two different things. I need to first find the volume of the prism, and then I need to find the volume of the cylinder, okay? In order for us to find the volume for each of these, I need big B and I need H. All right, let's work with the prism first. So if you look at the prism, your prism is a rectangular prism, and our bases are going to be this piece right here. It's going to be this front piece. Okay, that's a base, and then the other one is back here. That's the back base, okay? So big B is area of the base. Our base is a rectangle, so we're just going to multiply 20 by 15. So 20 times 15 gets me 300. So that's big B. And then remember that your height is always going to be the length that connects your two bases. So for us, that's going to be 50 centimeters. I need to make sure this is all in the right units. Yeah, okay. So this is 50 centimeters. Now what I need to do is find the volume of the cylinder, and big B is pi r squared. So I need the radius, and it tells me that the diameter of the hole is 8 centimeters. So I know from one side to the other is 8 centimeters, but I only need half of that to get the radius, which will be 4. So This is pi r squared. 4 squared is 16, so that's going to be 16 pi. And then the height is actually the same height that the prism is because the length of the cylinder is the same length as the prism. So this will also be 50 centimeters. Okay, so what I need to do now is multiply these things together. So 300 times 50 gets me 15,000. Got to check my zeros. And then over here, I've got to do 16 pi times 50. So 16 times 50 is 800. So this is going to be 800 pi. And then I have to subtract these things from each other. Now, when you plug this in the calculator, it does say round to the nearest cubic centimeter, which means that I actually have to put pi in my calculator. So this will be 15,000 minus 800 pi. Okay, so this will look like this. We're going to do 15,000 minus, and then in parentheses, I'm going to put 800, and then I'm going to put the pi symbol, which we get, if you see the button that says clear, right underneath the button that says clear, there's the little, what I like to call an up caret or the house top. And right above that in blue is a little pi symbol. So in order to access the pi symbol, you have to hit the blue button first. So you'll hit second, and then you'll hit pi. So just one more time, you'll do 15,000 minus, and then parentheses, you're going to do 800. You're going to do second, and then you're going to do the little up caret, and then close your parentheses. And that is going to be the value of the remaining volume. What does it say to round to? It says round to the nearest cubic centimeter, which is the nearest whole centimeter. So I got to go back here. We got 12487, it looks like. So this will be 12487. So 12,487 centimeters cubed. There you go. All right, last example, example 5. The volume of a cylinder is approximately 1,000 cubic centimeters. If the approximate diameter of the cylinder is 14 centimeters, how tall is the cylinder? My God, how tall is the cylinder? Round to the nearest centimeter. So we've got another cylinder. Here she is, beautiful cylinder. It says the volume is that if the approximate diameter, so from one side to the other is 14, we only need half, which is going to be 7 for our radius. It says how tall is the centimeter, so I'm looking for the height. They gave me the volume, which is big B times H. We want to be more precise, so this will be pi r squared times height. They gave me the volume as 1,000 pi. My radius is 7 squared times your height. 49 pi times H. Okay, you guys, this is so incredibly important. If you listen to nothing else in these notes, you better listen to this, okay? I am going to have to divide by 49 pi, right, to get H by itself. Here's the problem. I can't just divide by 49 pi. You must. There is no way around it. You must put 49 pi in parentheses. The reason that it's important is because the calculator is assuming what you're doing right now. It like when you divide this, like if you actually put this in the calculator is going to show you this. 1,000 divided by 49 pi. It is assuming that you are multiplying 49 and pi together. So what's going to happen is the calculator is going to follow PEMDAS, and the calculator is going to do this first, and then it's going to take whatever that answer is and multiply that by pi. But I'm not multiplying by pi. I'm supposed to be dividing by pi. Pi has to stay in the denominator with 49. So when I plug this in the calculator, it's going to look like this. And that way, the calculator understands that 49 and pi stay together. I will show you that you will get 2 different answers if you do not do it this way. Nope, that's what I'm working with. Here she is. Okay, ready? We got 1,000 divided by, this is me doing it the wrong way, 49 pi. I get this answer. Or 1,000 divided by, parentheses, 49 pi, close the parentheses. Those are 2 very different answers, okay? That is why it is imperative for you to keep the pi in the parentheses with 64 or with 49, whatever that number is, so that the calculator knows that 49 and pi stay together, okay? So what did it tell me to round to? Why does it keep doing that? It's annoying. It says round to the nearer centimeter. So we want the nearest whole centimeter, which I think would be, where am I? 6. So the height is approximately 6 centimeters. And there you go. And those are your notes over cylinders, guys. If you have any other questions, please go see your teacher during their normally scheduled tutorial times, and I will see you in the next one. Bye.